Okay, in exercise week 3, you need to solve or get the solution of Kinderwood problem. Okay, so to solve the problem, you can use the graphical method. So to get the solution, first step is you need to draw the straight lines. Okay, so by ignoring the sign of inequality in every constraint, you just draw the straight line for each constraint. For the first one, so I have already give you the tips. Okay, to draw a straight line, you just need to get the intercept point on x1 and x2 axis. Okay, for example, in the first constraint, to get the x1 intercept, which is where x2 equals to 0. So we get here x1 equals to 50. So the point intercept on x1 line, x1 axis is 50, 0. And then to get the x2 intercept, just substitute x1, 0, you get x2 equals to 100. So the intercept point on x2 axis is 0, 100. Okay, then you connect both points, then you will get a straight line. Okay, so sama juga untuk second constraint and the third constraint. This one is very easy. The intercept point on x1 axis is 80, 0, and on x2 axis is 0, 80. Okay, and for the third constraint, we will get a vertical line. Vertical line where the line pass through point 40, 0. So kita lukis. Okay, the first constraint. Okay, now then kita tahu the first constraint, you need to label each constraint so that you tahu yang line ni represent which constraint. Since the sign of inequality in the first constraint is less than or equal to, so I know that many students will just guess that the area is under the line. Okay, memang kebanyakan student akan buat macam tu. Which is correct, betul. Tapi actually you need to make sure, you need to confirm that the area is, that you choose the correct area. Okay, so in the video, I want you to choose any point, okay, to make it easy to calculate. Okay, if you assume the line is the area below the line, so you just choose any point below the line. Okay, so yang paling senang is point 0, 0. Because 0, 0 also lies under this constraint. Okay, so 0, 0 substitute into the constraint. We get 2 times 0 plus 0 is 0. Then 0 is less than 100. Which is true, betul. 0 is less than 100. Then we confirm that the area is under the line. Okay, so kita dah tahu, kita dah shade the area. Shade, okay. Dalam kerja awak kena shade. Okay, gunakan pencil, shade. Okay, lightly shade the area. Okay, jangan pekat sangat lah. Very light, so that you tahu dia punya area is under the line. Same to the second constraint. Just if you guess the area is under the line, so tak apa, just choose any point. Macam tadi kita choose 0, 0. Substitute into the constraint. 0 plus 0 is 0. Then 0 is less than 80. Okay, so it satisfies the inequality. Okay, so the area is also under the second constraint. Okay, just shade the area. Okay, and then the third one is x1 equals to 40. Okay, so tadi saya tak label pula garisan ni. Okay, then kita shade the first constraint tadi, ni second constraint, and the third constraint. Okay, x1 is less than 40 is all x1 that less than 40. Semua nilai x1 yang kurang daripada 40. So kita tahu dia on the left side of the line. Okay, dan satu lagi I nak stresskan kat sini ialah the sign restriction. Sign restriction. Why we stop the shading the area sampai the x1 and x2 axis only? This is because of the sign restriction. We need to set all the variables are non-negative. Semua x adalah non-negative. x1 and x2 are non-negative. Why? Because x1 represent the number of wooden toy. Maksudnya x1 adalah wooden car ke train? I tak ingat tadi. Okay. So X1 is the number of toy. Sama juga untuk X2. Number of toy. So it is impossible to get negative number of toy. Okay. So dia tak logik. Tak mungkin dapat nilai X yang negatif. Sebab tu adalah objek. Objek toy. Toy tu tak boleh nilai yang negatif. So that's why kita set the sign restriction. Okay, so since X1 and X2 are non-negative, so we cannot shade the area side of X1 negative kat sini. Kan bila second quadrant, okay, kalau second quadrant kat sini, X1 is negative. Okay, dekat on the left side of the X2 axis ni adalah untuk nilai X1 yang negatif. So, kita tak boleh shade sampai kuadran yang kedua. Okay, sama juga kalau untuk X2 are positif, maksudnya X2 all non-negative. So, kita tak boleh shade sampai area yang masuk kuadran yang keempat. Kat bawah ni. Tak boleh sebab all X2, the value of X2 below the X1 axis are all negative. Nilai X2 yang negatif. So, dia tak satisfied the sign restriction. So, that's why you punya area semua mesti on the first quadrant. Okay? Semua dalam first quadrant. Okay, bagus. Sebab ada 2-3 student yang tanya kenapa kita tak boleh nak shade kat belakang ni. Sebab itulah, sebab sign restriction. Okay, so then we get the feasible region. Okay, the region that satisfies all the constraints. So, we label the feasible region. Ataupun kalau you tak label pun tak apa. You need to stress the area. You need to highlight the area. Kalau ada highlighter, you highlight dia punya border. Okay, ataupun boundary of the feasible region. So that kita tahu. I know that is the feasible region. Okay, jangan you tak stresskan kawasan dia. Perlu stresskan. Okay, ataupun tulis kat dalam ni feasible region. Baru kita move to the next step is to draw the objective line. Okay, ni pun banyak soalan juga. How to draw the objective line? Okay, since we have 3 variables in the objective function. We have Z, we have X1, we have X2. Okay, we know X1 and X2 represent the X1 and X2 axis. How about Z? Actually, kalau you susun balik function ni, you akan dapat Z represent the intercept of the objective line. Kalau you susun lah, tapi saya tak tunjuk kat sini. Okay, you susun balik X2 on the left hand side. Okay, maksudnya X2 tu represent Y, kemudian you susun on X1 on the right hand side, you akan nampak Z tu sebenarnya adalah intercept. Okay, represent the intercept of the line. So, that's why Z can be assigned to any value, any number. Okay, boleh jadi apa-apa nombor. Dan cara yang paling senang macam saya terangkan sebelum ni, Z tu kita pilih adalah gandaan sepunya. Gandaan sepunya bagi nilai 3 dan 2 kat sini. Apa gandaan sepunya? Untuk 3 dengan 2. 3 dengan 2. So, dia punya gandaan sepunya paling kecil adalah berapa? 6. Tapi kita kena consider juga dia punya scale on X1 and X2 axis. Okay, nampak kat sini you have 10 by 10. 10, 20, 30. Yang ni pun sama. 20, 40, 60 by 10. So, 2 digits number untuk dia punya skala X1 dengan X2. Okay, so that's why you tak boleh pilih Z sama dengan 6. Sebab kalau you pilih Z sama 6, you akan dapat very small line. Very small. You nampak kecil je kat sini. Titik je kat sini. So, you boleh double up. Ataupun you boleh increase, choose Z larger than 6. Okay, you boleh pilih 50, tak kisah apa-apa nilai. As long as you can divide that number easily with 3 and 2. Boleh bahagikan dengan senang tanpa ada remainder, tanpa ada baki. Okay, so that's why saya pilih kat sini 60. Very easy. 60 divided by 3 is we get 20. Okay, so 60 divided by 3 is 20. Then we get X1 intercept. And then X60 divided by 2, we get 30. Then we get X2 intercept. Okay. Then kita boleh lukis dia punya objective line. Baru dia very clear lah. Menampak dia dekat sini. And make sure the objective line must touch the feasible region. Means at least not all or a part of the objective line must touch the visible region. Macam ni saya lukis, objective line dia touch the visible region. Okay, and then since the problem is to maximize Z, we need to move the line parallelly upward. Gerakkan dia ke atas. Sebab kita punya objektif tu maximize Z. So, garisan objective line tu you kena letak pembaris, kemudian you gerakkan ke atas. Parallel. Make sure you tak tukar dia punya gradient. Okay, tak tukar gradient of the ruler. Ruler yang you gerakkan tu. Okay, so gerakkan ke atas until it touch the last point on the visible region. So, tadi gerak and the last point it touch is this point. Okay, if you use the graph paper, so you can easily detect the coordinate of the point. Okay, nampak is 2060. But if you just draw on a plain paper, then you need to make sure your graph is accurate. Okay, betul, tepat lukisan dia. Okay, baru dapat coordinate dia 2060. Then this point represent the optimal point. Okay, optimal point where x1 is 20 and x2 is 60. Alright, this is the optimal solution and then optimal value. Okay, optimal value is Z value ni, nilai Z. Okay, we substitute x1 equals to 20 and x2 equals to 60 into the objective function, then we get Z. Z is 180. Okay, so tahulah. So you know that x1 is the number of wooden car. Saya tak ingat x1 is wooden car or train. I think a wooden truck. So x1 is wooden car. Okay, so we know that Kinderwood should produce 20 unit of wooden car and 60 unit of wooden truck per week. Okay, and gain a profit of 180 ringgit. Okay, so ini nilai-nilai yang you dapat tu, you faham lah apa maksud X1 dengan X2. Dan juga nilai Z. Z represent the profit. Okay, now about the ColourWorld problem. Okay, sama juga macam step Kinderwood, kita draw every constraint. Okay, so kita lukis the first constraint. The blue line represent the first constraint where the availability of raw material P. Okay, if I'm not mistaken. Okay, so when we substitute x1 equals to 0, we get x2 is 6. Okay, and when x2 equals to 0, we get x1 is 4. So, the first constraint represents the raw material of the availability of raw material P, and C2, the red line represents the availability of raw material Q. Okay, Q, and then constraint 3 represent the third constraint, which is the interior pane cannot exceed the exterior pane by 1 ton, more than 1 ton. Okay, yang tu. So we know that the difference between exterior pane and interior pane cannot exceed 1 ton. Kita dapat constraint x2 minus x1 less than or equal to 1. Okay, and then the last constraint is the demand for interior pane. So ColourWorld cannot produce more than 2 ton per day. Okay, per day. So ini saya harapkan semua dapat graf yang sama. Okay, then you shade the area, and then from here we know that the visible region is this one, dark purple. Okay, sama juga tadi kan. Okay, ramai yang juga confused. Dia shadekan area di belakang paksi X2. Okay, tak boleh. Tak boleh sebab bila you shadekan area di belakang X2 means you still choose X1 negative. Tak boleh. X1 cannot be negative. Okay, that's why kita ada border. Okay, boundary where X1 and X2 are non-negative. So this is the area, visible region, then draw the objective function. Okay, ataupun kita panggil dia sebagai isoprophic line. Okay, because we want to maximize the profit. So we call that the objective function as isoprofit line. The function is 5x1 plus 4x2. Okay, here I choose 10. So first, sebab tak kisah, as long as Z yang you pilih tu, bila you lukis dalam graph, nilai objective line tu mesti touch the visible region. Okay, yang macam ni tadi, not all but half, a part of the objective function lies on the visible region, touch the visible region. Okay, so then kita baru tahu kita nak gerakkan ke atas ataupun ke bawah. Okay, jangan pilih terlalu besar sebab kalau besar, Z besar, nanti dia akan keluar daripada visible region. Tak boleh. Okay, make sure dia touch the visible region. Now, when Z is 10, okay, you get this objective line ataupun isoprofit line. Then, since we want to maximize the profit, we need to move the line upward. Okay, parallelly upward. Okay. So, gerakkan ke atas. Okay. So, mula-mula kalau awak pilih Z lagi kecil, you akan start dengan kat bawah ni lah. So, dia akan first touch the point E. And then move lagi. Dia akan touch point L. Okay, lagi gerakkan lagi. Touch point M. And then point K. And last one is point N. Okay. Point N is the last vertex that meet the isoprofit line. So, point N is the optimal point. The optimal point represent the optimal solution. Okay. So, from here we know x1 is 3 and x2 is 1.5. 3, 1.5. Itu kalau you gunakan graph, kertas graph. Kalau you tak gunakan kertas graph, you tak boleh simply guess the coordinate. Tak boleh nak teka, tak boleh nak anggarkan, tak boleh. You need to find the exact coordinate. How to find the exact coordinate? The coordinate of point N. If you didn't use the graph paper to draw the graph. So, how to find the coordinate of point N? So, you know kan, N is the intersection between constraint 2 and constraint 1.
Simultaneous equation ke, Doktor?
Yes, good. Siapa? Nobert ke?
Ya, Doktor.
Yes, okay, good, Nobert. Intersection between line 2 at constraint 2 and constraint 1 can be found by solving both constraints simultaneously. Selesaikan dia secara serentak. Buat persamaan serentak. Okey, antara persamaan constraint pertama dan juga persamaan constraint kedua. So, you will get at the exact coordinate of this point. Okay, boleh? So, you akan dapat 3, 1.5. Good. So, x1 is 3 and x2 is 1.5. Then, substitute this value into the objective function. You will get z equals to 21. But don't forget the unit, the amount of the profit is in 1,000, dalam 1,000. Okay, so you need to multiply 21 by 1,000 ringgit. Therefore, you get the profit of ColourWorld problem is 21,000 ringgit per day. So, tahulah apa maksudnya. X1 is the ColourWorld should produce 3 tons of exterior paint and 1.5 ton of interior paint per day to gain profit of 21,000 ringgit. X1 intercept X2. X2 intercept X1. Okay. So, kalau siapa yang tengok video saya untuk week 4, I have mentioned about binding and non-binding constraints. Okay. So, binding constraint is a constraint that when we substitute the optimal solution, we get the left hand side equals to the right hand side. Okay. So, ataupun if you really understand about the binding and non-binding constraint, binding constraint represent the constraint that give us the optimal solution. Okay, macam ni kalau you tengok pada ColourWorld problem, okay, we know that the optimal solution come from the intersection of constraint 1 and constraint 2. Therefore, constraint 1 and constraint 2 are the binding constraints. Yang mana constraint yang bagi kita optimal solution, itu adalah kita punya binding. So, others are non-binding. Maksudnya, constraint ketiga dan constraint keempat adalah non-binding constraint. Ni tadi itulah yang saya baru cakap tadi. So, saya minta awak carikan untuk ColourWorld. So, saya dah jawab soalan tu. Okay, yang ni pun saya tak perlu nak terangkan pasal dia punya complete model sebab saya dah bagi jawapan complete model. Now you need to answer question A, B and C. How many types of watchband should be made to maximize the revenue? Okay, the question is you need to know how many girls and boys watchband should be produced. Okay, tak ada. Okay, so tak apa. Kita tahu dia cuma tanya berapa bilangan boys dan girls watchbands should be made to maximize the revenue. So, dia nak tahu nilai X1 dengan X2. Okay, macam tadi kita boleh selesaikan dengan menggunakan kaedah graph sebab kita hanya ada 2 je decision variables. Okay, then B, yang ni pun saya rasa semua dapat jawab lah soalan A dengan B ni. Maximum revenue means you need to give the Z value. Okay, optimal value. Okay, optimal value. Okay, yang C ni mungkin ada yang tak berapa clear lah. Okay, tak apa. Okay, so ini adalah graph untuk watchband, workshop watchband. Okay, ini pun sama, saya tak labelkan dia. Okay, saya kena labelkan. Okay, kita perlu labelkan setiap constraint pula supaya kita senang nak tahu. Intersection between two constraints give us the optimal solution. Okay, kita ada apa? First constraint is the availability of ladder. Okay, the availability of ladder is 50 inches. Okay, so the workshop only have 50 inches of ladder. Okay, a unit of boys watchband use 6 inches of ladder. Okay, and a unit of girls watchband use 4 inches of ladder. Okay, so 6x1 plus 4x2 must less than or equals to 50. Okay, so mana yang dia punya? Okay, yang ini warna purple. Okay, this is the first constraint. When x1 0, x2 is 50 divided by 4 is 12.5. The purple line represent the first constraint, and then the second constraint is the availability of steel. Okay, so the workshop only have 54 grams of steel, and to produce a unit of boys watchband, the workshop use 9 grams of steel and girls watchband use 3 grams of steel. And they both 9x1 plus 3x2 must less than or equals to 54. Okay, so which one? 54 divided by 3. So we get 18. Right, okay, the green line represent the second constraint. And the third constraint is the demand. Demand for girls watchband. Okay, line warna merah ni. Okay, so kita shade the area for every constraint. And then we get the feasible region. So the feasible region shaped like trapezium. It's trapezium. Okay, bentuk yang warna macam maroon coklat ni. Okay, so it has 4 vertices. Okay, ada 4 vertex. So now kita lukiskan dia punya objective line. Okay, the objective is 15x1 plus 12x2. So kita nak pilih nilai apa? Kita boleh pilih Z sama dengan 30, tak ada masalah. Okay, ataupun divide by 30 divide by 12, 2.5. So, tak ada masalah jugalah. Okay, kalau you lukis kat sini, 2.5. Dan bila 2 dengan 2.5, kat sini lah. Okay, kalau awak pilih 30, Z sama dengan 30. Okay, garisan dia macam ni. 2.5. So, still touching the feasible region. Still on the feasible region. Kita tak kisah apa nilai Z yang you pilihkan. Asalkan mesti sentuh feasible region. Okay, sekarang kita gerakkan dia ke atas sebab kita nak maximize the Z. Okay, maximize the revenue. So, dia gerakkan ke atas. First, dia akan touch point F, and then next point E, and the last one is point J. Okay, from the graph, the coordinate of point J is 4, 6. Okay, therefore, the optimal solution of this problem is x1 equals to 4, x2 equals to 6. Okay, and then to get the maximum revenue, we just substitute x1 and x2 into the objective function. We get the Z value ataupun the optimal value. Optimal value is RM132. Okay, now soalan C. What is the leftover? Baki ataupun lebihan bahan mentah. Lebihan bahan. Just focus on the constraint. We know we have number of leather, steel, and the demand. Okay, steel and demand. Okay, so kita check one by one. Okay, we know that the workshop have 50 inches of leather. Okay, so is it the workshop use all 50 inches of leather? All leather ataupun ada leftover? Kita tahu dia produce 4 boys washband and 2 girls washband. Okay, so how many inches of leather have been used in the production? Masukkan nilai X1 dengan X2 dalam constraint yang pertama. Berapa you dapat? Because we know to produce a unit of boys washband, the washband maker need to use 6 inches of leather. Okay, satu unit gunakan 6 inches of leather. Okay, if 4 unit, berapa gunakan? So, 4 times 6 is 24. And then, to produce a unit of girls washband, 6 inches of leather has been used. Okay, so to produce 6 girls washband, so the washband maker use 24 inches of leather. So tadi 24 plus 24 overall is 48 inches of leather. Betul tak kelas? But the workshop has 50 inches of leather. So ada leftover tak?
Ada 2.
Ada kan? Berapa leftover dia?
2.
2. So ada balance 2 inches of leather. Okay. Tapi untuk steel ada balance tak? Ada ni tak? Baki leftover?
Tak ada.
Tak ada kan? Dia pakai cukup-cukup 54 grams steel. Okay, untuk demand ada tak pengeluaran yang extra? Demand for girls washband is 6. Okay, 6 demand. Maximum demand adalah 6. And this workshop produce 6 girls washband. So, tak ada leftover juga untuk girls washband. So, hanya ada 2 inches of leather. Lepas workshop ni complete buat dia punya proses. Ada tak soalan setakat ni?
Clear, doktor.
Clear, okay. Okay. Kalau tengok pada modul, minimization problem example 2.4. Okay, go to example 2.4 minimization problem. Okay, cuba baca and try to formulate the model. Try to determine the decision variables, find x1 and x2, and then get all the constraint.
Type of program. Tamarida and the berita utama. So I took as the S1 and S2.
Okay, so you detect the x1. What is the keyword that you know that x1 is the 1 minute at during Tamarinda? Tamarinda, yes.
Based on the two type of the word two type of program.
Okay, so 2 type of program. So from here, 1 minute commercial spot. Is it? Okay, good. Okay, thank you, Kailing. Okay, good. Okay. So, betul lah apa yang Kailing cakap tadi. Okay. So, to find the decision variables of the problem, okay, first you need to know the objective function, the objective of the problem. Okay. So, this company is a telco company. Okay, which they have new service. They want to promote their new service to the customer. Okay, so one of the way to promote the service is by advertising it in the TV, okay, during the commercial break. Okay, so this company aim to minimize the cost. So the cost come from the 1 minute commercial spot purchased by them during the Tamarinda, and also 1 minute commercial spot purchased during the berita utama. Okay, faham tak kelas? So dia bukannya nak maximize the profit. So maksudnya kalau dia maximizekan profit dia come from the customer. Maksudnya how many customer subscribe ataupun join the new service. Betul tak? Dia punya profit. Itu kalau kita fikir secara logik lah, kita punya company tu profit datang daripada customer. Join the program tu ataupun join the service tu kan. Okay, so itu daripada profit. Tapi sekarang ni kita punya problem is to minimize the cost. And the cost come from maksudnya the company need to pay to the TV program. Okay, dia kena bayar kepada stesen TV. Okay, yang mana dia pilih untuk keluarkan dia punya iklan ataupun advertisement during the two slots, Tamarinda and berita utama. So as Kailing said, okay, X1 will be the number of 1 minute commercial spot purchased during Tamarinda slot. Okay, and X2 is the number of 1 minute commercial spot purchased during berita utama. Okay, so they need to decide. Jiji Mobile, Sendian Berhad need to decide how many 1 minute commercial spot need to be purchased during Tamarinda and how many 1 minute commercial spot should be purchased during berita utama so that they can minimize the cost. How to define the decision variables? Objective. Minimize the cost, so cari produk ataupun statement yang bagi tahu tentang cost. So, cost kat sini kan datang daripada 1 minit Tamarinda ad, okay, yang dia purchase, okay, dan juga cost datang daripada 1 minit berita utama ad purchase, okay. So, itu adalah X1 and X2. Alright, good. Okay, now kita pergi kepada function, objective function. Okay, so yang ini pun maklumat dia straightforward. Okay, the company want to minimize the cost, and the cost, kita cari semua maklumat dalam passage ni, ada tak pasal cost? Ada. Okay, so since we define X1 as 1 minute Tamarinda ad purchase and X2 as the 1 minute berita utama ad purchase, therefore the objective function of this problem is minimize Z equals to 50,000 X1 plus 20,000 X2. Alright? Okay, sekali lagi saya stresskan kat sini. Ramai juga yang saya check dalam Google Classroom, ramai juga student yang tulis X1 sama dengan girls watchband. X2 equals to boys watchband. Macam tu. Ataupun kalau Kinderwood problem, X1 equals to wooden car. X2 equals to wooden truck. Which is not correct. It's tak betul lah. Macam mana you define you punya decision variables. Kalau you define macam tu, kalau you cakap X1 sama dengan number of wooden car, so I tak tahu the color of wooden car, the material used to produce wooden car. So you kena specify kan, bagi tahu detail. Okay, X1 is the number of wooden car produced per week. Macam tu. Semua lengkap. Okay, sama juga dalam kes ni. Kalau you tulis X1 equals to 1 minute Tamarinda ads. So, saya pun tak tahu apa benda 1 minute Tamarinda ads. The number of 1 minute ke, apa lagi yang kemungkinan yang lain. Okay, so you kena specifykan dia. Bagi detail. X1 number of 1 minute Tamarinda ad purchase. Okay, yang dia beli. Kalau siapa tulis yang macam tu, macam saya cakap tadi, X1 equals to 1 minute Tamarinda ad, X2 equals to 1 minute berita utama ad, so automatic saya akan tolak markah kat situ. Sebab tak complete. Now, tadi saya dah bagi tahu objective function dia to minimize the advertising cost. So Z is, ada juga yang lupa nak tulis. Dia tak tulis pun minimum ataupun maksimum dekat sebelah Z, sebelah objective function. Perlu tulis sebab kita tak tahu kita punya objective to minimize or to maximize the objective function. Alright, so kalau tak ada juga perkataan min atau max pun saya akan tolak markah. This one 50,000 x1 plus 20,000 x2. Or you can simplify this function as z equals to 5x1 plus 2x2. And then in bracket times 10,000 ringgit. So kena ingatlah selepas tu you kena darabkan dengan 10,000. Alright, then the objective, the constraint of the problem. We only have two constraints. Okay, the first constraint apa dia?
Betul, saya try.
Kylie again.
Commercial apps that seen by men at least 12 million.
Alright, good. Okay, good. Bagus, betul. Okay, the target. Okay, the target. This company target that the advertisement watched by at least 12 million men viewer. So dia nak kena pastikan sekurang-kurangnya 12 juta penonton lelaki. Okay, so itu adalah first dia punya constraint. Itu adalah nilai untuk right hand side. Okay, left hand side dia cari apa maklumat yang berkaitan dengan men viewer. Okay, so daripada statement, okay, the commercial must reach at least 12 million men, at least. Okay, ada keyword dekat sini, at least. Dia target sekurang-kurangnya, at least. Means more than 12 million men. Dia target must more than 12 million men watch the advertisement. Okay, so daripada data yang ada dalam slide sebelum ni, kita tahu 2 million men watch Tamarinda and 5 million men watch berita utama. We know that, okay, the constraint, the first constraint is 2 million x1 plus 5 million x2 must greater than or equal to 12 million. Okay, sebab dia kata at least, dia mestilah more than. Okay, mestilah kena sekurang-kurangnya 12. So, dia 12 and more. Okay, 12 and more. So, kenapa saya tak tulis 2 million x1 plus 5 million x2 greater than or equals to 12 million? Sebab I can cancel out all these zeros. Boleh buang semua kosong-kosong tu. Sebab semua yang sama. 2 million plus 5 million greater than or equals to 12 million. So, I can cancel out the million. Okay, so dapatlah 2x1 tambah 5x2 greater than or equals to 12. And the second constraint is same as the first constraint, but now the target is the woman viewer. Okay, the commercial must reach at least 10 million women. Okay, 10 million woman viewer must be watched by at least 10 million women. Okay, so we know that during Tamarinda slot, there are 4 million women watch the program and 1 million women watch berita utama. So the target at least 10 million women watch the advertisement. Okay, at least sekurang-kurangnya. So kita dapat 4 million x1 plus 1 million x2 greater than or equals to 10 million. So we cancel out all million, all m. So kita akan dapat 4x1 plus x2 greater than or equals to 10. Ada lagi tak constraint yang lain? Tak ada?
Ada.
Tak ada, okay. Memang tak ada pun, bagus. Okay, tak ada. Ada 2 je constraint. So easy for you to draw the graph. Only 2 constraint. This is the complete model, the objective function, the first constraint and second constraint, and also don't forget the sun restriction. The number of 1 minute at purchase tak boleh negatif. Dia kena beli at least kosong. Sekurang-kurangnya kosong. Okay. So now kita draw the first line, the first constraint. This is the first constraint. Okay, first constraint. And then second constraint. Oh, sorry. Okay, then kita shade the area. Okay, since the first constraint has greater than or equal to sign. Okay, so kita assume the area on above the line. Okay, area dia di atas barisan ni. Okay, so kita boleh ambil je apa-apa titik di atas garisan constraint pertama ni. Okey, contoh yang paling senang kita boleh ambil nilai 1, 3 lah. 1, 3 kan berada di atas garisan. 1, 3 substitute dalam left hand side, kita akan dapat 2 plus 15. So 2 plus 15 is 17. 17 is greater than 12, which is true. Okay, therefore we can shade the area. Okay, actually area dia semua lagi besar. Okay, lagi besar. Maksudnya bukan stop sampai 6 saja. Dia lagi besar sebab saya pakai PowerPoint, saya tak dapat nak extend dia punya area. Okay, kalau you lukis dekat dalam you punya modul, you shade sampai macam ni lah, dia atas lagi, okay? Tapi make sure jangan lebih daripada first quadrant. Okay, next draw the second constraint. Okay, ni pun sama, saya tak cukup space, saya buat separuh, dia tak tunjuk sampai X2 intercept. So sepatutnya kena sampai X2 intercept lah, lagi nampak lagi okay you punya graph. So lukis sampai X2 intercept and then shade the area. Okay, pun sama juga, sepatutnya dia punya area pun atas lagi, sampai lebih besar daripada apa yang saya lukis ni. Okay, lagi atas, lukis lagi atas. Since we need to find the area that satisfies these two constraints. Okay, so from here we know that the area is this one. Actually is unbounded. Dia tak ada nampak garisan macam ni. Okay, jangan lukis garisan. Okay, saya harap tak ada pelajar yang lukis garisan macam saya buat ni. Salah ni. Tapi sebab saya pakai PowerPoint, saya tak dapat nak tunjukkan yang dia unbounded. So dia punya region tu tak ada border. Tak ada border ataupun tak ada boundary pada bahagian atas dan tepi ni. Tak ada. So dah ada visible region. Label it. Okay. Then draw the objective line ataupun isoprophic line. Okay, so since our objective is to minimize the cost, so we need to give any value to Z. Okay, then make sure the isoprophic line touch the visible region. Okay, so what is the most suitable value of Z that you can choose? Apa nilai Z yang paling sesuai yang kita boleh bagi pada objective function kita? Kita ada objective function
10.
Tiong. Alright. Okay, thank you Tiong. Okay, Tiong choose Z is 10. Okay, what happen if you choose Z equals to 10? Okay, when Z equals to 10, X1 is bila X2 0, X1 is 2, and when X1 0, X2 is 5. 0, 5 and 2, 0. Yang saya gerak-gerakkan cursor saya ni, arrow saya ni. Okay, 0, 5 and 2, 0. Okay, nampak tak kenapa saya tak pilih 10? Okay, kalau you pilih 10, garisan dia tak touch the visible region. Then you cannot move the line. Maksudnya, suppose if the objective function is to minimize the cost atau minimize Z, so you should move the line downward, gerakkan dia ke bawah. Okay, tapi sebab sekarang kalau you ambil Z sama dengan 10, you tak boleh gerakkan ke bawah sebab tak ada visible region. Okay, tak ada visible region. Okay, tak boleh gerakkan ke atas. So that's why you kena increase Z. Pilih Z yang lagi besar, bigger than 10. Okay, tadi 10 tak boleh. How about 20? Okay, kalau 20, X2 is 10. Okay, X2 10. Dan X1 is 4. Boleh. Okay. X1 4. So, boleh. Okay, you boleh pilih Z sama dengan 20. Okay, so you akan ada garisan yang macam saya gerakkan ni lah. Okay, boleh. Okay, tapi saya pilih 30. Pun boleh, tak ada masalah as long as the line touch the visible region. Okay, so saya harap semua clear. Okay, macam mana nak pilih nilai Z? Boleh pilih apa-apa saja nilai Z dengan syarat graf yang awak lukis, isoprophic line yang awak lukis tu mesti sentuh ataupun berada pada feasible region. Okay, ini saya punya objective line. Okay, when I choose Z equals to 30. Okay, now since the problem is to minimize Z, we need to move the line parallelly downward. Gerakkan dia ke bawah secara selari until it touch the last vertex ataupun the last extreme point. So, kita gerakkan dia ke bawah, gerakkan lagi, then this is the last point it touch. Okay, the isopropyl line touch this point. So, what is the coordinate of this point? How to find the coordinate of this point? Okay, again, if you didn't use the graph paper, you need to solve the constraint 1 and constraint 2 simultaneously. Selesaikan secara serentak. Everybody already get the intercept point of this, the coordinate of this extreme point. Kita akan dapat nilai. Okay, besides solving these two equations simultaneously, you also can multiply the second constraint by 2 so that you get the coefficient of x1 becomes 4. So 4, 10 and 24. Then you can subtract ataupun buat operasi tolak antara constraint pertama dengan constraint yang kedua. So 4 minus 4, you get 0. So we already cancel out x1. So we have 1 minus 10, which is 9. Negative 9. Negative 9x2 is equal to 10 minus 24. So we get negative 14. Okay. So negative 9x2 equals to negative 14. So we get x2 is 14 over 9. Okay, 14 over 9. Then substitute x2 into any of these equation. You get x1 equals to 19 over 9. So after we get the optimal solution, okay, x1 and x2 represent the optimal solution of the problem. You need to get the optimal value, which is nilai z. Okay, what is z value? Okay, substitute x1 and x2 into the objective function. Okay, which is the objective function is 5x1 plus 2x2. You will get 41 over 3. Okay, 41 over 3. Kalau you gunakan nilai x1 dengan x2 bentuk fraction. Okay, kalau you gunakan decimal, saya tak sure berapa nilai dia. Tapi jangan roundedkan dia kepada 2 ataupun 1 tempat perpuluhan. It's very dangerous sebab dia akan effect nilai yang lain. Okay, nilai z. Alright, so kita akan dapat 41 per 3 dan jangan lupa dia dalam bentuk 10,000. Okay, dalam value dia 10,000. So, kena darabkan dengan 10,000. Therefore, 41 over 3 times 10,000, you will get 136,666 ringgit and 70 sen. Okay, ini nilai dia. Itu kalau kita dah darabkan dengan 10,000. Okay, kalau tadi kalau you rounded terlalu awal, okay, maksudnya tadi you dapat, mungkin you ambil tadi 19 per 9. Okay, you ambil x1 sama dengan 2.1. Okay, contohlah kan, 2.1 x1. And x2 sebagai 1.6. Okay, betul? Kalau you masukkan dalam ni, nilai z, you akan dapat berapa? 5 kali 2.1 campur 2 kali 1.6, awak akan dapat 13.7. Okay, 13.7. Bila 13.7 kalikan dengan 10,000, you akan dapat berapa? 137,000 ringgit. Banyak ralat dekat sini. So that's why jangan rounded too early ataupun jangan rounded kat jawapan awak tu masa awak solve the equation simultaneously. Awak selesaikan secara serentak. Jangan bundakan dia terlalu sedikit, kecil. Okay, biarkan dia dalam banyak decimal places. So baru you boleh masukkan dalam nilai Z. Baru akhirnya, last one, when you want to declare what is x1 and x2, the value of x1 and x2, then baru you roundedkan dia lah. So means from here we know that Jiji Mobile Sdn Bhd should purchase 2.1 at during the Tamarinda slot and 1.61 minute at during the berita utama. So 2.1 minit semasa Tamarinda dan 1.6 minit semasa berita utama. And the cost is 136,666 ringgit and 70 sen. Itu cost dia. Dan ini awak kena tahulah. So 2.1 minit equals to 2 minutes and 6 seconds. 2 minutes and 6 seconds at during Tamarinda slot and 1 minute and 36 seconds during berita utama slot. Okay, kalau logik pun kalau you tengok berita atau you tengok TV, okay, during your favourite program, you akan nampak kalau dia ada sponsor, contohnya selalunya sponsor bagi program tu adalah macam handphone, Oppo ke, kan? Selalu ada Samsung ke, dia akan sponsor satu program. Okay, so bila you tengok you punya favourite program tu, you akan nampak iklan yang sama keluar. Okay, iklan Oppo tu banyak kali keluar. Tapi kadang-kadang you nampak iklan dia panjang. Kadang-kadang iklan dia pendek. So maksudnya pendek tu mungkin dalam kes yang macam ni tadi 1.6. So 1 minit dan 36 saat. So satu iklan tu 1 minit, satu lagi iklan dia ambil 30 saat, 36 saat. Okay? Itu maksud dia lah. Okay, jangan jadikan dalam bentuk integer. Okay, jangan rounded kepada bentuk integer. Tak semestinya jawapan tu dalam bentuk integer.
Betul.
Ya?
Just nak tanya a bit yang S1 ini 2.1 dengan S2 1.6 ini bukan number of purchase meh?
Ialah number of 1 minute at purchase. Satu adalah 1 minit. Kalau 2 minit.
Means dia purchase berapa minit macam tu?
Sebab dia kata 1 minit tu, so sekarang ni 2.1 minute at purchase. Okay, maksudnya 2.1 adalah berapa minit? 2 minute and 6 seconds. Betul tak? So mungkin dia boleh apa nak cakap macam ni? 2 kali 1 minute at purchase. Tak boleh lah. Maksudnya tak semestinya you kena pilih 2 kali. So you boleh ambil 3 kali. Maksudnya 3 kali adalah, maksud saya 2 untuk 1 minit dan satu lagi mungkin untuk 6 second. Faham tak? Clear tak masalah Jiji ni?
Faham.
Faham? Okay. So saya pun susah nak explain, tapi sebab kebetulan X1 is the number of 1 minute at purchase. Okay, 1 minute. So kita ada X1 equals to 2.1. So the number of 1 minute at purchase during Tamarinda is 2.1. Okay?
Okay.
So tak apa, nanti you boleh tengok balik, you comparekan dengan solution yang kita bincang hari ni dengan statement yang dalam example 2.4 ni. So you akan relatekan lah, boleh you nampak dia punya jawapan dia kena relatekan dengan situation Jiji.